Hello, so continuing on problems from this weekly contest 329. The third problem is apply bitwise operations to make strings equal. So we get two strings, S and target, and each of them has only 0 and 1 values. So you can think of them as a binary strings. And we can do only one type of operations, but any number of times. And this operation is basically taking two different indices, right? And I and j, and replacing s of I with s of I or s of j, and replacing s of j with s of I XOR s of j, right? So we take I and j, different indices. They don't have to be in some specific order, they just need to be different. And then we assign to s of I, we replace it with s of I or s of j, this value. And then s of j, we replace it with s of I XOR s of j, okay? So for example, if we take this string, then we can, for example, take position 0 and position 2. So this would be I and j. And we can replace, that would mean, if we do this operation, it would mean replacing s of I, which is 0, with s of I or s of j, which is 0 or 1, which will give you 1, right? 0 or 1 will give you 1, so that's what we have here. And then s of j, s of 2 needs to be s of I XOR s of j, so it would need to be 0 XOR 1. And so 0 XOR 1 is still a 1, and so we have this one here, okay? So this is the result that we get. But the goal is basically to see if, given s and target, if we can make s equal to target, and we are allowed to do as many of these operations, as many of this operation as we need, okay? So let's take the first example here. I hope that made sense. So for example here, this is, if we take I to be 2, and then j to be 0, then we can, then what will happen is that s of I will be s of I or s of j, so basically s of 2 would be 1 or 1, right? Which would be 1, okay? And so here that would mean, that would mean we have 1 here. And then for s of, s of j would be s of I XOR s of j, so it would be s of I, which is 1 XOR 1, so it would be 0, so we'd have 0 here. And then the second operation would be to pick I to be 2 and j to be 1, and then from there we will get 0 1 1 0, which will give us the exact target. And so it is possible, okay? But with this one, it's not possible. You can try different combinations to see if you can make it happen, but it won't be possible. So how can we approach this, right? It seems pretty tricky. And we can't try all different binaries really, because n can be really long, okay? So let's see how we can solve it. So the first thing we need to think about here is that, so I just have here the formula that the problem gives us. And then on this side, I have just a reminder of what OR operation does and what XOR operation does, right? Okay, so now let's just try and see. Let's not think about all of the string. Let's think about just two positions I and j, right? So for two positions I and j, what are the different possible combinations, right? We know that we have only 0 and or 1, right? Those are the only two possible values. And so what if the character at I was 0, the character at j was 0? The other option is one can be 0 and the other can be 1. And so the two combinations are these two. And then the last one is that both are 1s. So these are the only possible combinations of the values on I and j. And so if we do the operation, so here we do the operation that the problem says, which is this here, okay? So if we do, if we have both are 0, then 0 or 0 is 0, right? So s of I stays 0, and then 0 XOR 0 is also 0, so it stays 0. If we have 1 and 0, then s of I is going to be 1 or 0. 1 or 0 is 1. And then S of j is going to be 1 XOR 0, and 1 XOR 0 is also 1, so we have 1. And same thing, similarly, 0, 1 gives us 1, 1. 1, 1 gives us 1, 0, because 1 or 1, that's 1. And then 1 XOR 1 gives us 0, so we have 0, okay? So this is just like showing you what are the different combinations. Now, if you were solving the problem, it would be, to come up with the solution, it's, you should have thought about, or you need at least to think about, okay, what are the different possible combinations, and let me see if there is a pattern. And that's where a pattern may surface to you here. So the first observation we can make here is that if S doesn't have a 1, so it's all zeros, then we can't change anything. We can't change it, right? So either it was equal to target and then we return true because it was equal, or it's not equal and so it's not possible, we return false. Why is that? Because if you take a look at this here, 0, 0 always gives you the same value. You can't change it, okay? And if you take a look here, why is that? That's because if we take a look at this one, 0 or 0 gives you 0, right? And you can see here also, like, 0 XOR 0 give you 0. And when you have 0 here and you OR it with 1, it will stay the same. And when you have 0 and XOR it with 1, it will stay the same, right? So when you have 0 as S of I, you can't change the value no matter what you do. You can't change it, okay? So that's the first thing. The second thing to observe is that, so the other observation is that if you have, if S in S, you have a value of 1, like here or here, then there is no way you can change that to be all zeros, right? Because this will give you 2 1s, this will give you 2 1 and 0, right? Okay? And even here with 0 and 1, you still get 1 1. So once you have at least a single one, you can't get 2 zeros. You can't get zeros. You can't change it to all zeros, right? And so that means if S has a 1 and target has all zeros, we can't have a solution, right? Because once you have a 1, you can't change it to all zeros according to these variations that we saw here, right? And so the second observation is basically that if S has at least a 1, right, then we can't change to all zeros in for target, right? And actually, believe it or not, these two will give you enough to solve the problem, because, well, how do we basically translate these to code? So the first one, basically, we can check if it says that if S doesn't have a 1, which means we can just check if 1 not in S, right? Then that means we can't change S. So it's either they are equal, then we return true, but if they are not equal, we return false. So we can just check if they are equal, this will return true, which is what we want. If they are not, we return false. So that's the first thing. The second, so that took care of this. The second part says if S has at least a 1, then we can't change it to all zeros. So what does this mean if we write it differently? This basically means if target is all zeros, which basically means 1 not in target, that's what it means, it's all zeros, then S we need S to be all zeros, otherwise there will be a problem, right? So here what we can okay, so here how do we check that one? So if we get here, right, then we know that 1 is in S. Okay, because otherwise we would have entered here and returned, right? So if 1 is in S, that means it has at least a 1. Then we can't change to all zeros. So this means that it will work only, so let's say if 1 is not in target. So now we know 1 is in S, but 1 is not in target. Okay? Then here the only chance we have for it to work is that if they are equal, right? Similar to the previous one. Why is that? Because, so, well, actually, let me just throw that back. So here, this means false. Because here we know that 1 is in S. Okay? So we know that it has at least S. We know that we can't change it to all zeros target, right? So if 1 is not in target, that means target is all zeros, right? And so that means we should just return false. Now, we did the second condition. Okay? And so now we just need to return true because we did the both conditions. Okay? And that's it, right? So we're just using these two observations from these. But in all other cases, this is an important observation also. In all other cases, it should be possible to transform because let's say there was a 1 case that is not here. Let's say there was a 1 in both. Let's say there was a 1 in I and 1 in J, right? Then in that case, we can fix one of them and transform the other one to 0. And we could do that with as many places as we need, right? So we'll just fix this one, transfer this one to 0, and then go to the next position where there is a problem and transfer it to whatever value we need, right? And even the other one, if you have only a 1, 1, then you can transform this 0 to a 1, right? And even if you have a 1, 1 here, you can transform this 0 to a 1 here, right? So all the other cases work fine. Like by work fine, I mean you can convert S to target for that position, except these positions. So basically we'll look at this and we figure out what are the cases where we can't make S equal to target. And it's just those cases here, those two observations. And that's what we translate here, okay? I hope that was clear. Just run it on some examples. Think about it a little bit more if it's not clear, and hopefully it will, you'll understand it. Now let's write the code and make sure it passes. Okay, so let's write the code for this here. So what do we need? We said that we just need to check if 1 is not in S, then we want to return S equal to target, right? So the only way for them to be equal is if they were already equal, because we can't transform. Now if otherwise, this means 1 is in S. So here 1 is in S because we didn't enter the previous if. And so here if 1 is not in target, so target is all zeros, we can't get rid of the 1 in S because there is no 1 in target to use for that, so we return false. Otherwise, all the other cases should work fine, so we return true. And we can submit this, and that passes fine, okay? Now, you could simplify this a little bit more, right? So you could just check basically if, right? This here or this, right? Because if this is not in S, right? So if this is in S, 1 is in S, then we are here. We can just check this, and this will be false, or it will return false, and so we'll end up with this. So you could decide to simplify it like this, okay? And this should work the same way, okay? Yeah, so in terms of time complexity, well, this is constant time, so of 1 time, of 1 space as well, nothing extra we are using here. Yeah, and that's pretty much it. Please like and subscribe, and consider supporting me on Patreon. as well. And thanks for watching. See you on the next one. Bye.